All right, so like I said, we continue with our past paper revision, and today we're doing math. So we're going to start with this math paper one paper. It was written in 2020, and as usual, these papers are paper one is worth 80 marks. And the bad part about paper one is that it's usually the hard paper because you don't choose. So for this one, you have to be really, really careful to just try and figure out what you know. So if you are, and you know it's timed, and there is no calculator, you answer all questions. So the first thing that I can encourage you to do in paper one is that when you have this paper, sort of skim through it to see what you can answer and what you cannot answer. Maybe get like a pen and put some stars or dots to questions that you're familiar with, like factorization, expansion, some functions. Just put certain dots on here on those easy questions, and then make sure you answer those questions extremely well. After you answer those questions extremely well, you can now start answering the hard type of questions. But again, the format of this paper does not change. Questions always come like this. So all you have to do is just know the principle and know the right way to solve the question, and things won't be hard for you. So it's answer all questions, no calculator. Let's begin. At least we do 5 questions because at least I have a deadline. So whatever you can't see here, if you can't see the question properly this side, I'll be able to write it properly on the working side. So if you can see, at least question one is, by the way, can you at least see the questions? Now, can you at least try, man, are you able to see the questions somehow? Hello? All right, just unmute yourself so that you can respond. All right,
Yes.
you can, all right, that's the thing I wanted. Okay, so the first question is rather easy, but the next question is a little bit tricky because it involves indices and standard form. And like I said, I was supposed to teach you that topic, but I'll see what I can do today during the explanation of that question. We'll see how we can apply all the rules one by one. But let's start off with this easy question. It says simplify. So simplify means just you are removing brackets and then you are collecting the like terms. So you have got a question which says 2a plus, open brackets, b minus a, close brackets, minus 2h. So to expand, we multiply by the first thing that we see outside the brackets. And what do we have outside the brackets here? We have got this positive 1 here. It's just a plus 1. We're not going to say, we're not going to indicate it with a 1, but just know that there's a plus 1 there. So this plus 1 is going to multiply with the b and the minus a to expand like so. So once we expand, we're going to have 2a. This will be plus b minus a, because positive 1 multiplied by positive b, it will be positive b. Positive 1 multiplied by minus a, it will be minus a, minus 2h. Then the next step is just to collect like terms. As you can see, the only like terms we have is this one here. Wait, this is b, sorry, yeah, this is minus b, not minus h. The paper is a little bit faded. So this is minus b and this is minus b, all right? So we now have like terms, a and a, b and b. So if we collect like terms, we'll have 2a minus a plus b minus 2b. So again, remember that when you're collecting like terms, the integer value remains the same. Positive b is still positive b, minus a is still minus a, negative 2b is still negative 2b, positive A is still positive A. Nothing is crossing the equal sign. You are just bringing them together. You are collecting like terms. So if we subtract 2A minus A to give us A, then positive B minus 2A, again, you ask yourself which number is bigger between 1 and 2. You say it's 2, meaning the answer is going to be a negative. When you say positive times negative, it's negative, meaning you are subtracting. So it would be like 1 minus 2, which is 1. So this would just be B. So our simplified version becomes A minus B as our answer. You get your 2 marks. So let's now try moving on to this question here, which will require me to work through it. It will be slightly long, but please follow the solution. So this topic here, it actually says 64 over 125, close brackets, raised. So it's a fraction raised to a power. So you're going to see how we're going to expand a fraction that has been raised to a given power. So this topic here is indices and standard form. So if we have an index or a number that's raised to another power, let's say it's been raised to the power of m. So if I can say a raised to the power of m, this number here will be the base. And then this number that you see above here is called the power, or you can call it an index, or you can call it an exponent. So this is the indices notation. You're going to have a number which is a base, and you have got a power which is an exponent. And this exponent here can be anything. It can be a positive, it can be a negative, it can be an integer. It could be anything. But this base here, normally this base shouldn't be a negative. If you have got a negative base, you simply remove the minus sign and solve it as a positive value inside the brackets. But the power can be any integer. It can be a positive integer, it can be a negative integer. So given that this is the base and that's the power, there are about 5 rules. There are certain rules that you have to know of indices. So these rules only work if you have the same base. Do not attempt to use rules of indices when you are dealing with things that do not have the same power, or sorry, things that do not have the same base. So for example, we have got the first rule, which is the addition rule of indices. You have got, let's say, a to the power of m multiplied by a to the power of n. So you can see that the base is the same. So if given the same base and different powers, all you have to do is just add the powers. So this will be m plus n. How do I know this rule? How do I memorize this rule? Because this multiplication symbol here, if I rotate it, if I rotate this multiplication symbol, it's going to become an addition symbol. So that's how I know that, all right, if I've got things which have the same base raised to different powers, all I have to do is just add the powers. So I'm going to add the first rule here. It says a to the power of m multiplied by a to the power of n will give us a to the power of m plus n. But of course, we have to give an example. So if I have 2 raised to the power of 3 multiplied by 2 raised to the power of 4, I'll be like, okay, I have the same base and I'm multiplying this. So this will be 2 to the power 3 plus 4. Therefore, my answer will be 2 to the power 4, 5, 6, 7, 8. 4, 5, 6, 7. So 2 to the power of 7. So that would be my answer. I've got things that have got the same base. There's a 2, there's a base 2 there, raised to a different power. So what am I doing? I am going to simply add the 2 powers. So this will be 2 to the power 3 plus 4, giving us 2 to the power 7. So that's how you apply the first rule of indices. So let's look at the second rule of indices. Rule number 2, which is the subtraction rule of indices. So given things that have got the same base, so we've got a divided by a to the power of n, you simply subtract the powers. So if you have got two indices with the same base raised to different powers, all you have to do is subtract the powers. So how do I know this? How do I remember this rule? If I see indices being divided, what I usually do is that I just cancel out these two dots. If I cancel out those two dots in a division symbol, I'll be left with the subtraction symbol. So therefore, I'm going to know that, okay, if I've got two bases and we're dividing, I simply cover those two dots. And if I cover those two dots, it will be a subtraction symbol. So I have to subtract the powers. So for example, if I've got 3 raised to the power of 4 divided by 3 raised to the power of 2, I'll be like, okay, these are two indices on the same base. So what I have to do is subtract the powers. So this will be 3 to the power 4 minus 2. So my answer will be 3 to the power 2. So this is how you use the second rule of indices. I'll write it here. A to the power m divided by a to the power of n will give us a to the power of m minus n. By the way, you have to know these rules. So when I send you this video, you have to write down these notes, all the 3 rules and all the examples that I have given for the exam's sake, because you are going to find a question on indices and it won't be as direct. So the third rule is a power raised to another power, the multiplication rule of indices. So if I've got a base that has been raised to another power, raised to another power, I'll simply multiply the two powers. So a base raised to the power of m, raised to the power of n, what do? I simply multiply the two powers. So let's say I have got 6 raised to the power of 2, raised to the power of 4. So this will be 6 raised to the power of 2 times 4. So our answer will be 6 raised to the power 8. So this is how you use this rule. If you have got a power raised to another power, you just simply multiply the two powers. So I'm going to write the third rule here. You have got a power raised to another power, n, it has to be n to the different power. You have got a power raised to another power. What are you going to do? You just multiply the powers. So now what do you do in an event where you have got a negative power? So a negative power can be converted into a positive power by making it a fraction over 1. So if I've got an index like this, a to the power negative m, I do not want this negative power. So I have to convert the entire thing by making it a fraction over 1. So a to the power minus m is the same thing as saying 1 over a to the power positive m. So I've converted a negative power into a positive power by making it a fraction over 1. So for example, if my answer is 5 to the power negative 2, I don't want to leave it in this notation, so I can just say 1 over 5 to the power 2. So I've converted this negative power into a positive power by making it a fraction over 1. So this is our fourth rule. Our fourth rule, which says a negative power can be converted into a positive power by converting it into a fraction over 1. So let's look at rule number 5. Don't worry, they're just about 6 rules, not so complicated. You will remember them just if you have a little bit of practice. So our fifth rule talks about any number raised to the power of 0 is 1. Oh, any number raised to the power of, sorry. Okay, let me pause the. Okay, so we continue from the point where you got disconnected. So if I have a power raised to another power, all I have to do is multiply the two powers. So for example, if I have 5 raised to the power of 2 raised to the power of 3, what I'm going to do is just say 5 raised to the power of 2 times 3. Then my answer will be 5 to the power of 6. So if I have a power raised to another power, all I have to do is just multiply the two powers. Then at times when we're looking at indices, we usually get negative powers, like that question there. How do you deal with negative powers? So if you have got a number a raised to a negative power, you can make that negative index into a positive index by making it a fraction over 1. In this way, you're going to convert the negative power into a positive power by simply making it a fraction over 1. Please, you have to know these rules. So if I have 5 raised to the power negative 3, I can turn this into a positive power by saying 5 over 5 to the power 3. So I've made it a positive power by making it a fraction over 1. So that's rule number 4. A negative index can be converted into a positive index by simply making it a fraction over 1. You're not supposed to forget this. As a mathematics student, all these rules of indices have to be at your fingertips, because the only way to solve indices is just to play around with the rules. So I'll write rule number 5 here so that we can see all the rules that we're using. So rule number 5 says any number raised to the power of 0 is 1, regardless of the magnitude of the number. If I have 289 raised to the power of 0, it's going to be 1. So a to the power of 0 is going to be 1. So any number raised to the power of 0 is going to be 1. So now we look at our final rule, rule number 6, which states that if I have a fractional index, a raised to the power m over n, if I have a fractional index, the denominator, I usually like to remember this mnemonic as doctor. So I usually say dr, like for, oh, you're losing connection. Okay. All right, are you back?
Yes.
All right. Your internet is quite unstable today. I don't know, internet has been unstable. I don't know if it's the weather or something, I'm not so sure. So this rule says if you have a, an index that's raised to a fraction, as you can see, this is the fraction. Let me just write it um, a little bit closer. Let's say a raised to the power of a fraction. I like to remember it as a doctor. This is the doctor rule to me, because the denominator, the denominator, denominator, the denominator becomes the root. So that's what I say by doctor. The denominator becomes the root, and then the numerator becomes the power. So this is the denominator, that's the numerator. So this rule actually says if you have got a fractional index, the denominator becomes the root, so n. So n is the denominator, becomes the root, then automatically the numerator is going to become the power. So if I have a fraction like 3 raised to the power 1 over 4, it's going to become the 4th root of 3 raised to the power of 1. So you can see that here the denominator became the root and the numerator became the power. If I have another one, let's say 27 raised to the power 2 over 3, this is the denominator. So this is the denominator and 2 is the numerator. This is going to become the 3rd root of 27 raised to the power of 2. So the final rule is the doctor rule. If I have a fractional index like so, the numerator is going to become the root and then the denominator, oh sorry, the denominator is going to become the root, it's the doctor, so the denominator becomes the root, then the numerator becomes the power. So these are the 6 rules that we're going to use to solve this question that looks complicated, but it's actually not, it's easy. As long as you follow, you first follow the rules properly, you'll be able to answer this question without difficulties. So let's apply the rules to this question. So we have got 64 over 125 raised to the power negative 1 over 3. So a fraction that has been raised to a power, we have to expand it like this. So the numerator is going to be raised to that power, and the denominator will also be raised to that power. So here we're going to have 64 to the power negative 1 over 3 divided by 125 to the power negative 1 over 3, like so. So now the next thing that we're going to ask ourselves is, how we don't want these negative indices. So how am I going to convert a negative index into a positive index? I'm going to use this rule here, rule number 4. So I'm going to convert 64 to the power 1 over 3 and 125 to the power negative 1 over 3 into fractions over 1. So how are we going to do this? We're going to say 1 over 64 to the power 1 over 3. You've seen that, right? I've converted this negative power into a positive power by making it a fraction over 1. Divided by, we'll do the same with the denominator, 1 over 125 raised to the power 1 over 3. So I've converted this negative power into a positive power by making it a fraction over 1. So now here I'm going to use the doctor rule. I'm going to use the doctor rule to simplify it further, which says if I have a fractional index, the denominator becomes the root and the numerator becomes the power. So moving on, this is going to be, remember they are fractions. So we're going to say 1 over 3 is the denominator, so it's going to become the root, and 1 is the power. So I'm going to say 1 over the third root of 64 raised to the power 1 over 1 over the third root of 125 raised to the power of 1. So you've seen that, right? I have used this rule. The 3 has become the root and the 1 has become the power. So that's what we're doing here. Okay, so let me continue it from there. So what are we going to end up with? The third root is a number that we can multiply 3 times to get 64. If we multiply 4 by 4, 4 by 4 will be 16. Then 16 by 4 will be 64. So a third root is a number that we can multiply 3 times to get back that number. So 4 times 4 times 4 will give us 64. Therefore, the third root of 64 is going to be 4. Raised to the power 1 is just going to be 4. So on top there, we're going to have 1. Let me solve it slightly closer. On top there, we're going to have 1 over 4 over, what's the third root of 125? A third root, again, is a number that you can multiply 3 times to get back that number. So we can say 5 times 5 times 5 will give us 125. Therefore, the third root of the 125 is 3. Raised to the power 1 is just 3. So we're going to have 1 over 3. So now we just convert this into a division form. We're going to have 1 over 4 divided by 1 over 3. We convert this to a multiplication symbol. We'll end up with 1 over 4 multiplied by 3 over 1. The numerator becomes the denominator and vice versa. So our final answer will be a fraction of 3 over 4. So we've used certain rules of indices to answer this question. How have we answered it? Step 1, we expand. This goes to the power, that goes to the power. It becomes 64 to the power negative 1 over 3 over 125 to the power negative 1 over 3. We convert them into a positive index by saying 1, by making them fractions over 1. So 1 over 64 to the power 1 over 3 divided by 1 over 25 to the power 1 over 3. Then we use the doctor rule. The numerator becomes the root, the denominator becomes the root, and the numerator becomes the power. So here we've got the third root of 64, which will be 4 times 4 times 4. So the third root of 64 is 4. So we'll end up with a fraction of 1 over 4 in the numerator. Then here in the denominator, the third root of 125 is 5. So we're going to end up with a fraction, oh sorry, this is 5. Where did I get this 3? So we're going to end up with a fraction of 1 over 5. So this will be 1 over 4 divided by 1 over 5. Yeah, 1 over 5 there. 1 over 5. We change this into a multiplication symbol. It will be 5 over 1. Therefore, our answer will be 5 over 4. Or if you want, you can say a whole 1 over 4. If you want to convert it into an improper fraction, it doesn't matter. They'll still give you marks whether you leave it as a proper fraction or an improper fraction, as long as you show all these steps. And how did we get to the final answer? We just simply manipulated the rules of indices. So I urge you to just repeat these rules and then try to solve this question once more. So our answer here is 5 over 4. So we'll say 5 over 4, or a whole 1 over 4. Okay. So let's move on to question 3. It all makes sense once you just start revising these videos. And get a piece of paper and you have your tuition book, write down the question, use the video to quickly run through the questions over and over. Things are going to make sense eventually. Let's try answering the next question, which is coordinate geometry. Geometry on the X or Y plane. It's an interesting topic. Okay, so for coordinate geometry, you have to know how to read, that's all. You have to know how to read and how to manipulate the equations. Once you know those two things, everything is going to be easy. So let's see if we can try to read this question together. Let me use this blue. So given that the line y is equals to x plus 6, we've been given two lines, given that the lines y equals, 3y equals x plus 6 and y equals k plus 12. Okay, k plus 12. And they are saying they are perpendicular. So find the value of k. So to solve this question, you have to know two things. The first thing that you have to know is the formula for an equation of a straight line, because these are straight lines. So the equation of a straight line is y equals mx plus c, where m is the gradient. So the gradient is a coefficient of x. By now, you should know what a coefficient is. It will be a number that appears in front of the variable, and our variable is x. So our gradient here is m. The gradient is the coefficient of x. So gradient will be represented by m. And this c here, please, in coordinate geometry, it's not a constant. It's the y-intercept. It's the y-intercept. It means this is the point where this line, it's a line like that, y equals mx plus c, and this would be the y-intercept. The y-intercept means it's the point where this line cuts the y-axis. So in linear form, when we're talking about coordinate geometry, this c is not a constant, it's the y-intercept, the point where the straight line cuts the y-axis. So that's the first thing that you have to know to answer this question. And then the next thing that you have to know to answer this question is that perpendicular lines have negative reciprocal gradients. Perpendicular lines, you have to write this, have negative reciprocal gradients. What do I mean by this? If I've got two perpendicular lines, let me denote this by, or you can also say the product of gradient one of one line multiplied by the product of the gradient of the other line will give you -1. So this equation just summarizes this negative reciprocal. So what do I mean? If the gradient of, let's say line 1 and line 2, let's give various scenarios. If the gradient of one line is 5, how do I say negative reciprocal? You know, if you are standing straight like this, the reciprocal of yourself will be you going down on the floor like that. So the reciprocal is just the upside down version of any whole number or a fraction. So if one line is has a gradient of 5 and they are perpendicular lines, the other line is going to have a gradient of -1/5. If one line has a gradient of -3/4, remember it's a negative reciprocal. So if one line has a gradient of -3/4, the gradient of the other line has to be the negative reciprocal. So you multiply by negative and you make it upside down to be +4/3. If one gradient has if one line has a gradient of let's say 6, the other line is going to have a gradient of -1/6. If one line has a gradient of maybe let's say -2, the other line is going to have a gradient of +1/2. So you just get the negative reciprocal such that if we say gradient 1 multiplied by gradient 2 has to give us -1. This cancels, that cancels, you have -1. That cancels, that cancels, that cancels, that cancels, you have -1. That cancels, that cancels, you have -1. That cancels, that cancels, you have got -1. So this is the information that you have to know in order for you to answer this question in coordinate geometry. So let's see how we can apply this knowledge that we've just learned. How can we apply this knowledge to answering this question? So once I send you the video, you write down these notes that I'm saying in detail, literally write down everything in your book. Then you go back and try to answer this question. So let's what do you call this? Let's complete the puzzle piece. Let's apply what we've just learned. So we know the equation of the line is y is equal to mx plus c. And we have got two lines here. So the first one is y equals, or 3y equals x plus 6. And the other line is what? Y equals kx plus 12. So the good part about this one, it's in linear form. It's already in the form y equals mx plus c. But this one here is not. So we have to make y the subject of the formula here so that we can have we can express it in this form, in the form y equals mx plus c. So how are we going to make x the subject? Let me just write it better. How are we going to make x the subject there? We're going to say we divide both sides by 3. We divide both sides by 3. Y will be x plus 6 over 3. Then we'll say y will be 1 over 3x plus 6 over 3. So this same denominator here that's dividing this fraction, you bring it there and you bring it there. Because here, remember when you're adding fractions, this is the lowest common denominator. So you can actually split this into 2 individual fractions by saying this is 1 over 3x plus 6 over 3. This can go back to this. You just say the lowest common denominator is 3. You divide and multiply. You're going to get back to x plus 6 over 3. So you can reverse this process by just bringing the denominator and the numerator together. So this will be 1 over 3x plus 6 over 3. If we reduce it even further, it will be y equals 1 over 3x plus 2, because now we're going to divide like that. So we've expressed this line here in the form y is equals to mx plus c. So the only thing that we have left is to bring the equations together and interpret. So we have got the first equation, which we've just converted in the form y equals mx plus c. Y equals 1 over 3x plus 2. And then the next one will say y equals kx plus 12. So what are we interested in? The value of k. The value of k is what? The gradient, and they are perpendicular. So the gradient over this line here, line 1, is 1 over 3, and the gradient of the other line is what? K. Because they are perpendicular, the gradient k will be the negative reciprocal of this one here. So what are we going to do? We'll convert this one into a reciprocal, and we'll say, okay, meaning it will be 3, right, over 1. So I'm not going to say 3 over 1, it's 3. But it's a negative reciprocal, so it will be negative 3. Therefore, our value of k will be negative 3. So that's how we solve this question. I know math right now looks like a lot, but all you have to do is just know the methods of solving and practice. So this method, this question, again, it's going to come the exact same way, to be literally the exact same way. They'll just say change a few variables, but the exact same way of getting to the answer. So please revise, revise, revise. If you don't understand something, you can text me on WhatsApp. If you find some questions, text me on WhatsApp. I can help solve them for you. It is so that we proceed quickly. So let's solve the last 2 questions, because I have to go edit my research proposal. At least this one, the last 2 questions won't be that hard. Maybe question 5, because I'm seeing magnitude there. But this one, at least, it's just factorization, and we've done a lot of questions in terms of factorization. So let's see. Let's write down this question. So it says factorize. It's very long, but it will be easy. So 6ax minus 4ay minus 3bx plus 2by. So what we're going to do here is we'll split this equation because it's long, so we'll split it into 2 things like so. Then we'll factorize this separately. We'll factorize this separately. How do we factorize? We look for a common factor and or variable. So we have got a common variable. There's an a here. There's an a there. So we'll put the a outside. There's a factor, right? 2 can go into 6 and 2 can go into 4. So we'll put the 2 like that. And then we'll divide this entire expression by 2a over 2a. Here, what do we have? We've got a b, we've got a b there, but we have the negative there. So what's going to come out to be a minus b? So I've got a minus, we have the b and the b there, but what to come out because of this would be a minus b in common. Open brackets, minus 3bx plus 2by. We'll divide the entire expression by minus b over minus b. So the a will cancel. 2 there, 1, 2 there, 3. So we're going to be left with 3x there. The a will cancel. 2 there, 1, 2 there, 2. So we remain with 2y. So if we factor out this, we'll have 2a, open brackets, 3x minus 2y, close brackets, minus b, close brackets. The b will cancel, the minus will cancel, we remain with 3x there. The b will cancel, the minus will multiply with this, so we're going to have minus 2y. So minus 2y. We'll end up with these two that are the same. So we're going to say 3x minus 2y, and we'll say, oh my, all right, I really hope the internet won't cut out. But just watch the video. The video, it will be easy to follow once I send you the video. So don't worry whether you are being cut off while recording. So let's continue. So you notice that these, we have them in common. Don't worry, I'll explain this again. So we'll only write 1, then we'll combine these two. We'll end up with 2a minus b. And this will be our final answer. So our final answer is 3x minus 2y, close brackets, 2a minus b, close brackets. So you just have to factorize, honestly. That's the, you have to learn how to factorize. So if you want to learn how to factorize, you have to go back to the previous video on how to factorize, or I've actually explained how you actually factorize, then you come back and solve this entire question. So again, factorizing just involves finding the common factor and or variable, dividing by that common factor and or variable. If all else fails, use the difference of two squares. And if you have got this Chinom equation that you want to factorize, split it in two, factorize one separately, factorize the other one separately, and then bring what you have in common into one, and you are done. So don't worry, I'll send you this video, just go through the explanation. So let's solve the last question. At least we solve 5 questions because time of explaining is really time consuming. So right now here we've got certain coordinates. By the way, if you see this question and they say find, you've been given 2 coordinates like a minus 2 comma 1 and b, which is oh nice, okay, and b, which is 1 comma 5. What you are going to do here, when you've been given 2 coordinates, we've done vectors in physics and they say find the magnitude. You just have to know that here I'm using the distance formula. So you're just going to say magnitude of AB. You have to know this formula is the root of x2 minus x1 squared plus, open brackets, y2 minus y1 squared. So this is the formula that we're going to use. You have to know this. Unfortunately, you just have to know this. You have to know your equations for coordinate geometry. So what are we going to do? We have got A, which is -1 or -2 comma 1, and we have got B, which is 1,5. So I'm going to show you the step-by-step method. Can you get me?
Yes.
All right, so you have got two equations there. So where there is this first equation, this is the x-axis. Oh, sorry, this is the x coordinate, this is the y coordinate, x comma y. Even B here, this is the x coordinate, that's the y coordinate. So just underneath the -2 here, you're going to say this is x1, this is y1. Then you go to the next coordinate, you say this is x2, and this is y2. Then you state the distance formula. The magnitude is the root of, open brackets, y2 minus, oh sorry, x2 minus x1 squared plus y2 minus y1 squared. After stating the formula, you start to substitute. So x2, we are like, okay, what is x2? This coordinate, you say 1. Minus, open brackets, what is x1? Okay, -2. -2, close brackets, plus, open brackets, what is y2? Okay, it's 5. What is y1? Okay, -1, close brackets. Equals to root of, now you expand. So what you're going to end up with, if you expand here to be positive, so it will be 1 plus 2, which will be 3, or there's a square in the formula. So it will be 3 there. So 3 squared plus, open brackets, here you're going to have 4. 5 minus 1, 4 squared. Okay. Then you say root of 3 to the power of 2 is 3 times 3, which would be 9. And then 4 to the power plus 4 to the power of 2, it would be 16. It's 4 times 4 is 16. Then you'll be like, okay, if I add these two, 9 plus 26, I'm going to get 25. Therefore, what am I doing? The formula has a square root. So I just have to square root this and I'll have 5 units. And that's my answer. So how did I solve this? We have to know the equation. Given two coordinates with their coordinates x1, here's my cursor, with their coordinates x1, y1, x2, y2, we can find the equation, we can get the distance or the magnitude between the 2 points using this formula, which says distance, let me put it in red, which says distance between 2 points A, B, or whichever points is the root of, open brackets, x2 minus x1, close brackets, squared, plus, open brackets, y2 minus y1 squared. Then you can start your substitution. All right, x1 is 1 minus, open brackets, x2 is -2, close brackets, squared. Why are we closing these brackets? Because the value there of x1 is a negative. So we don't want to make our index in error. Plus, okay, what is y2? 5. You put your 5 there. Minus, what is y1? 1. You put your 1 there. Close brackets, squared. You continue the equation. So root of, okay, this will, if we expand it to be positive, so it will be 1 plus 2. So it will be 3 squared. This will be 5 minus 1. It will be 4 squared. Root of 3 to the power of 2, it's 9, plus 4 to the power of 2, it's 4 times 4, it's 16. 16 plus 9, it's 25. Therefore, the magnitude is 5 units. So you have to know this equation for you to answer this question. So that's what you have to know to answer this question. So as you can see, with each explanation from question 1 to 5, I have given you all the necessary information that you need to answer that specific question accurately. And that's what math is about. And they won't change these principles. They are going to use the exact same principles each year in, year out, each year. Nothing is going to change. It's just the question that's going to change. So I urge you after this video, I will send you the lecture just now. Let me send it right now. I'll forget. I'll get crowded in work. Once I send, start practicing. Same with physics. Just keep on watching these videos, keep on watching these videos until you write that final paper. All right, I'll see you tomorrow. Is that okay?
Yes.
Let me send the video just now so that you can practice. See you tomorrow. Bye.